Even if you haven't taken physics before, a lot of the words that we use in this physics class will likely be familiar to you. Words like work, or momentum, or energy, or position, or even relative. The thing to be aware of is that in a physics context, we use these words with very precise meanings. So our colloquial, or another word for everyday use of the meanings of these words are not very precise, and often they're incorrect when they're used in a physics context with the colloquial meaning. A really good example of this that we'll talk about later in the quarter is the word work, but the same is true for the other words that I mentioned as well. Another good example is the word position, which we talk about in week 1. So often when we use the word position, colloquially, we kind of think of the object's location that can maybe be represented by a dot on a map. But in physics, position is actually a vector, an arrow, and to be able to define it, you have to first define some kind of a coordinate system, like this. And so if this is the location of the object, position is actually a vector that goes from the origin to the location of the object. So to properly specify the position of an object, you have to state both the length of this arrow and the direction of this arrow, and of course the coordinate system that you're referring to. So they're so important in physics is that they are a building block, one of the crucial building blocks, in fact, to understanding physics. There are really 3 things that we focus on in this class. The first is definitions, and then we use the definitions of words included in laws or theories of how the world works. So definition, laws, and theories can be expressed in words. They can also be expressed in mathematical equations. And it's really important to be able to use both forms because to understand what's going on, you should be able to explain things in words. And to solve problems, you'll have to be able to use these same ideas in math forms. So most physicists scorn the idea of memorization. We're not a field that thinks that memorization is a really important key to doing well. And yet, so the good news is that there aren't too many things that you have to memorize in physics. But there are a few things that are really important to memorize, and this is what they are: the definitions and the laws and the theories. So before you come to class on a day when we're studying something, we have a pre-class assignment, and the goal is for you to have read and to be able to recite the definitions or laws and theories. And this is really important because while we don't expect you to understand them fully, if you don't at least know what the topic is, what the definition and laws or theories say, it's really hard to have a conversation and engage in the material. So what we ask is that outside of class, you read and review and do your best to memorize these definitions, laws, and theories, and then in class, we'll work to help you to really understand them.